So let's assume there is a number x, okay, and we have given a value of 7. We have given a value of 7. And this is for everyone, okay? And if you are able to solve this, then there is some logical thinking that you're able to apply and algorithm you're able to develop. Once this entire algorithm is developed, we'll start putting it into a code. Please, everyone, contribute to this. Specific question being discussed here is, how do I write the logic of detecting whether a given number x is a prime number or not? So what do I need to do? Stepwise. I need to keep on. Good.
Making creating a loop, a for loop.
Okay. So step number 1 is loop. Okay.
Loop that starts from 1 to 7, like to the number we want to check for. We need to divide like the number.
Then
we need to divide the number by I, like.
Okay.
And if the number divides by I,
okay,
and then that would make it a non-prime number, because it should only have a factor,
okay,
which is either divisible by itself or divisible by 1.
agree.
And if it is not, if it isn't divisible by any of the values of I, you declare it as a prime number.
Agree. So let's say if I start my loop, first value of I will be 1 and 7 will divide by 1. So should I call it as not prime? So I think a better way is we start with value of 2, not 1. When in the loop, I start with I from 2. I start dividing by 2, not by 1, because every number is going to be divided by 1. Make sense?
Yes, sir.
So first division is going to be 7 divided by 2. If that division is not successful, I will just keep on checking more. If it is successful, I'll say stop there. The number is not prime, because some number I've been able to find so that the number is divisible. So if this is successful, then I say not prime. If it is not successful, what do I do?
We declare it as a prime number.
So you need to exhaust all these possibilities. If first number, let's say 2, 7 divided by 2, not divisible, I will not stop there. No? I'll just make one more division.
We increment I value and then put it in a loop.
Exactly. So basically, I will just keep on doing this in a repeated manner. Just repeat that and exhaust everything. I just ensure that all the values have been exhausted by incrementing, obviously. But since I'm already running the for loop and I have control over all the values of I don't need to increment, correct? Right? I think largely we agree. Let's just proceed further. So this part, this is one part, this is second part. Anything else that is required?
So to check, like to decide whether the number is prime or not prime, we need to have a variable so that we could use it as flag, and then
yes. So it can come once all of this. Basically, we exhaust all the numbers and we are still not here. We are exhausted all these numbers and still there is no division happening. So something as a check should be done, which tells us that all these numbers have been tried and tested. So some kind of a check is required that all these values of I have been tried, but none of them are able to divide the number 7. Everyone agrees to this? So let's step by step build this logic, okay? And I think when problems like these are discussed, that is where you start seeing the utility of everything that you've learned. For loop, kahan apply karna, while kahan apply karna, right? All of that will become clear. But for this simple problem, I will just use for loop. While loop is not required. Okay. So what I'll do next is just start writing the code for this. So first thing is, let's declare the value of x as 7. Then I need to start a loop in range. And what do I write in the range? See, just look at this first criteria. Value of I should vary from what to what?
2 to 7.
2 to 7. Right? And you do know that if I provide something like this, then the values that are created are 2 to 6, not 7. And we do not want the 7, right? Because 7, we know it is going to divide 7. So this will take care of the first part. Everyone sees that?
Yes, sir.
First thing that we wrote, it is going to take care of it. Now let's make the division operation happen. Okay. And we will put a condition because there is a yes and no, na? Do you see it? Yes and no. So
Yes,
there are
sir.
two possibilities. And for any such condition, we put a conditional statement. We say if. Okay. And we perform the division operation, which is 7 divided by I. So instead of doing 7 divided by I, we will make use of the modulo operator. Modulo operator, if you recall, we just looked at. So we say X percentage I, and we put it equal to 0. Is this okay?
No, sir. Double equals.
Yes. I wanted to show this because I wanted someone to point it out. So what will it generate in the first iteration? What value will it generate in the first iteration? This highlighted part. In the first iteration of the for loop, what will this generate?
The 7 modulo 2 is good. So
Right? So I can also make it happen outside. Okay, just be with me. So what I'll write is 7 modulo 2. And let's run this. This is going to give me remainder. So when you divide 7 by 2, you get a remainder of 1. And I'm trying to equate this remainder equal to 0. So just think aloud. Any number you divide by 2, right? You get the remainder either as 0 or 1. Make sense? And that is what I'm trying to check in this line. Is the remainder equal to 0? If yes, then 7 is divisible, right? If it is not, just return the remainder and let me check it against 0. So this is going to give you a false. And that is exactly what this shaded portion will give you. Okay, and let's now build the remaining. So once this condition is true, what do I do? Once this condition is true, what do I do?
So we print, we show that it is a prime number and we break out of the loop.
We can leave the loop. Okay, so we'll say, and I can use a F string. And what will I say?
It is not a prime number.
X is not a prime number, right? And this is something that I've already taught last time, right? How to use F string in a print statement, in a print function. Now this is done, and I do not want to repeat the other rounds of checks, right? If only one number is able to divide, I don't want to repeat the remaining iterations. So I'll break. Quickly, I'll just stop the loop. But if this is not true, then what will I do?
So, we print X is a prime number.
Okay, so I'll write else, and I will use the same statement, right? Is this correct, people? Tell me, is this making sense? And is it taking care of all the 3 checks that we have done here? I'll just quickly run the. So break is correctly used. Break is not an issue. The flow is going to this code, and the reason it is printing it so many times. So first of all, it is generating the right answer. First thing is that 7 is indeed a prime number. Just that it is printing it too many times, right? And just look at it. It is printing ones for value of I as 2, then 3, 4, 5, and 6. So in total, whatever numbers you're dividing 7 by, it is printing that. But we do not want this to be printed every time. For now, understand what is happening. Why this is printed again and again. And I'll explain that by breaking it down. When the value of I is 2, you're dividing 7 by 2. And it is not divisible. So the code flow goes to else block. And it goes to this statement. Printing X is a prime number. But we should not print it so early, because it could very well happen that 7 is divisible by some other number which comes after 2. Right? For example, if I put 39, right? 39 is not a prime number. 13 3 is 39. So just imagine when X is 2, this statement is not going to be true. This is going to be false. And then the flow is going to come to this, right? When x is equal to 2. This is not met. The code flow will go to the else block. And then you will print this statement that 39 is a prime number. Are you with me? And then when the value of x changes to 3, then this criteria will be true. And then you will print 39 is not a prime number. Let me run this. Right. So in earlier condition, when x was 7, it was giving us the right output, but we wanted less number of print statements. But when we change the value of x to something else, then that is where we see the flaw in the logic. Okay. And can I clear the screen? Can I get rid of all the scribble on the right hand side? Right. So something else is needed. And that is where we can go and shift this else in under the for block. Right. Now, before running the code, I want to show you and help you understand how the flow is really happening. Let's start with this example only. X is equal to 39. So first, when the value of when I is 2, this will be false.
Yes, sir.
Right. So the code flow will not go into this. But there is no else statement corresponding to this. Right. For the if block, there is no corresponding else statement. Right. So this will keep on running because all you have is this, right? Essentially, all you have is this, which is a simple for loop. So this for loop is going to keep on running. And till the time it is not entering inside this, it is not entering inside this, it is going to keep on exhausting all the values of I. Are you with me? Right? The only way we can break out of this loop is once this criteria meets. So any number that is prime number is never going to break out. The way we have designed this, it is never going to break out. So writing this for loop like this with only one condition, that is if, ensures that you are exhausting all the possibilities for a prime number. Okay. But if the number is not prime, then you will step out of the loop then and there. Right? If this is 39, then in the first iteration, 39 is not divisible by 2. So nothing is happening. Next iteration, the value of I is 3. So 39 is divisible by 3. And that is where the flow comes here and you step out. So this logic alone will work for all non-prime numbers. But for a prime number, it displays nothing. And let's run this. For 39, it is working. For 7, it is not going to display anything. Right, so this could also be a check. If the cell is not generating any output, it is a prime number. Are you with me? If it is not generating any output, then you can say it is a prime number. But when it generates, it does generate the proper statement. Now to get a proper output for a prime number also, let's say 13, I have to add a condition, which is the else condition. And this else condition applies for the for loop, not for the if condition. And that is how the alignment is, right? Now this does what exactly? This is ensuring that once you have exhausted all the iterations in the for loop, only then this line is going to get executed. That's what it is saying. So this is in a way taking care of that third check, which was there in that drawing. Na? Third part, third component. There was a check. Na? So this else condition is like a check, which says that have you exhausted all the possibilities of value of I? If yes, then only I will print this. Otherwise, I will not print. Right. So this is the logic for detecting a prime number.